Hello, this is Scott at MechSoft. In this video, I'm going to introduce you to some of the very nice 3-axis milling capabilities found in Alibre CAM. Using this demonstration part, I will create a few basic 3-axis milling operations that are commonly used to rough and finish parts similar to this. So I'll go to the Add-ons tab, choose Alibre CAM, then the Machining Operations browser, which will appear on the left of your screen. There are 3 things that need to be done prior to creating any machining operations. First, I'll define the stock material or workpiece shape. The system automatically creates a minimum box around all the geometry, and I'm going to increase the height of the top so that I'll get full cleanup on the part. Next, I'll define the work 0 or program 0, and I'll reference the stock box that I just created. I'll position the work 0 at the highest northwest corner of the stock, as you can see on the screen, and I'll save that. Finally, I've defined 3 cutters for this job, 2 ball mills, and a flat end mill with a corner radius. Each of these cutters has the tool number, feed rates, coolant, and so forth already defined as part of the tool definition. With those 3 things done, I'm ready to machine the part, and the first thing that I want to do is rough off all the excess material using a flat end mill. So I'll go to 3-axis and choose horizontal roughing as my first operation. This operation will automatically cut all the geometry on the screen, so I don't need to select any geometry here. For the tool, I will use the flat end mill. Feeds and speeds, make sure they are loaded from the tool. Cut parameters, I want to leave 0.6 millimeter stock on all surfaces, do climb cutting, and the step over will be 50% of the tool diameter. Cut levels, I want 30% of the tool diameter calculated as the depth of cut in Z. And I want to make sure that I clear the flats, because I do have flats in this particular part, and I want to leave that amount of stock on each one of those flats. At this point, I'm ready to generate the tool path. Now for these tool paths with levels, I can examine each individual level using this function below the browser. I'll simulate this tool path. The next operation will be a finishing operation, which will do parallel passes across the entire face of the part. To do that, I'll go to 3-axis and choose Parallel Finishing. Again, no need to select any geometry. I'll use the 12 millimeter ball mill, and I want to make sure that the cuts are parallel to the y-axis, which is at 90 degrees, and that the step over is calculated as 20% of the tool diameter, and I'll generate the path. And there's the tool path for the parallel finishing. As you watch the simulation, remember that I set up this operation to finish the part leaving 0 stock. But you can also effectively use this as a semi-finishing operation to knock down the large steps left by the roughing process and yet leave stock for later finishing. Now, to save time, I'm going to pause the simulation and run it to the end of the path without the tool display. And in just a few moments, you'll see the final results. And there it is. For this final operation, I'm going to again use parallel finishing, but this time, rather than cut the entire surface of the part, I'm going to contain the cutter to within a sketch, as you see on the part here. So I'll go to 3-axis, select parallel finishing, and I will select the sketch as a containment region. For the tool, I want to use the 6 millimeter ball mill. For the cut parameters, I'm going to embed this into the surface by a 0.5 millimeter, and I want the cut direction to be 0, which is along the length of the region. Now I can generate the path and simulate the path. Now that I've created these 3 representative operations, and assuming that the program is now complete, I'm ready to post-process this job. Post-processing converts the internal generic tool paths that you see displayed on the screen into machine-specific codes for your machine in the shop. Bear in mind that post-processing acts on highlighted objects. including individual operations if you wish. But to post-process the entire job, I'll select the highest object in the browser, the machining job, and use the right mouse button. I will select Post All. This panel comes up and gives me information about the destination directory where the posted output file will be deposited, the name of the posted output file and the extension of that file, as well as the name of the post processor that will be used. If those are all correct, I'll select the Post button. The output file is listed on the screen, and as a programmer, I'll quickly check things like the tool number, feeds and speeds, z-values, just briefly. If I find anything that is wrong, I'll go back to the original operations and correct them, and then repost the job. Well, that was a brief rundown of some of the basic functionality for 3-axis milling in Alibre CAM from Microsoft. I hope it was informative and helpful. Thank you.